one.
Hello everyone. We are Team 9 and our project is a cloud-based network performance simulator. To better understand what our project does, I will first introduce two different types of network architectures. One is the traditional network, which is basically the internet we use every day. The key components in the traditional internet are the routers and the switches. They're responsible for relaying the packets from the sender to the receivers. As illustrated on the left-hand graph, the routers embed both the control plane, which looks up the routing tables and decides where to forward the packets, and the data plane, which processes the packet information. In recent years, there's a new type of network model known as the software-defined networking, and it is shown on the right-hand side. It shares a similar infrastructure compared to the traditional network, and it uses switches as well for relaying messages. However, how the packets are forwarded is decided by the controller. In this way, the control plane and the data plane are separated in SDN. The key difference between the two network models is that the traditional network is distributed in nature, while routing decisions are made locally by the routers. On the other hand, SDN is centralized, with all routing decisions made by the software controller. We have listed a few different traits between the traditional network and SDN on the slide here, and there have been a lot of studies conducted on the general performance comparison between the traditional network and the SDN. However, when users build their own network environment, they may not have the time to look through the details, and the generic benchmark analysis may not fit their own use case. Therefore, our goal is to build a lightweight network performance simulator that allows the users to customize the network topology. The keywords here are lightweight and customization. By lightweight, we aim for minimal environment setup and installations required on the user's end. And by customization, we would like to provide an intuitive way for the user to set up and build their own network topology. Next, Damien will describe our tool in detail.
Okay, so so this is Damien speaking. So in this segment, I will be detailing the architecture that we've developed for our research project. Our aim was to design a simulation tool that not only aids in the performance analysis of software-defined networking, but also allows us to contrast it with the behavior of traditional networks. This overview diagram outlines the entire web architecture. Our front end is designed using React and its associated libraries, deployed through AWS Amplify. The middleware, which I will detail further, act as a secure communication channel through the AWS API gateway, interfacing seamlessly with our backend server. So let's dive deeper into the front end. We choose React as our front end framework, and with React Flow, we introduce interactive elements that empowers user to craft and manipulate SDN network topologies intuitively. We've also chosen end design to ensure that our user interface is not only functional but also aesthetically pleasing. The snapshot here illustrates how user can build their networks, set up their configurations, and subsequently view the simulation results. So for deployment, we choose AWS Amplify. It's a service that offers continuous deployment and hosting. With seamless integration to GitHub for our CI/CD needs, this ensures our application is always up to date with the latest code commits and is scalable to handle varying nodes. And next one is the middleware. AWS API Gateway acts as a secure bridge between our HTTPS-based front end and the HTTP-based backend, facilitating smooth and secure data flow. This proxy converts HTTPS request from the front end into HTTP request that our backend understands, and vice versa. It keeps the data moving securely and efficiently. And next one would be Stan.
Hello, everyone. My name is Stanislav. I was helping team to work on the backend I'll go over the backend architecture of our solution and explain the key parts of the setup. So our backend deployment, the backend was deployed on AWS EC2 instance. This allowed the team to quickly bring the solution online and start development process. As we know, AWS is very scalable and efficient, and we could spin up the instance very quickly and start development in the matter of a few minutes. For the backend architecture, we use the following 3 building blocks: Django, Mininet, and RYU controller. Django was used to connect the front-end user interface and the backend server. For our project, our team has used Python-based web framework because this framework is secure, reliable, scalable, and because of its Python foundation, it allows us to efficiently integrate with Mininet Python API. The second building block of our solution is Mininet. Mininet was selected by our team to perform the network topology simulation. As Mininet is widely known software to build software-defined networks, and it supports various controller types that can be used for variety benchmark testings. In addition, Mininet provides Python API interface that allows the team to efficiently parse the network topology payload that was shipped from the front end and recreate the same topology using Mininet functions. Additionally, Python API interface of the Mininet provides the function that help us to test the round trip time for the topology, sending the packets between all the hosts. Those functions were used by the team to run the tests and do the comparison between the traditional network topology and SDN and determine which one routes the packets better and which one is more efficient. And the third building block is RYU controller. RYU OpenFlow controller easily integrates with Mininet tool. That was the main decision for the team, why we chose the RYU controller. And it supports Python integration and has Python API, which makes it way easier for us to integrate it with Mininet and Django and make the integration quick and efficient. RYU controller provides the best throughput for the network topologies, and it's natively supported by Mininet, thus making it a great choice for our solution. So combining these 3 building blocks allowed us to develop an efficient tool that can deliver precise topology simulation results and show the comparison between the traditional network topology and the SDN, software-defined network. At the end of our implementation, the team has tested the efficiency of the traditional network and SDN topologies, and as the result, it confirms that SDN provides greater packet routing efficiency and lower round trip time as the complexity of the topology grows. Therefore, proving that SDN in certain cases is better than the traditional network topology and allows end user to test these different implementations on their own. Next, I'll give it over to Thomas to present the demo of our solution. Thomas, over to you.
Okay, yeah, I'm Thomas. Next, I will give you a brief demo. So first, let's open our project web page. And on the left, you can see the section of the project we are currently in. And to the right, these are the basic controls and some network components. So in the center, we show a default network topology, and we allow users to create their own topology and to simulate and compare. So in our demo, we will explore 3 different network topologies, including the single topology, linear topology, and triangle topology. So now let's dive into the single topology first. And for this one, I will walk you through the step by step, showing how we operate and configure the network. So we can delete the components we don't need, and we can add some host here by swiping here, and we add the host we need. Like, yeah. It's just a simple one, and we connect them by, yeah. And now we will send a request to test this network, and this JSON file we send to the backend. We just click send. Yeah, let's wait a moment for the result. All right, so here is the test results. As you can see in this topology, it seems that the traditional network is better than the SDN. Yeah, maybe it's more simple than the others. So the traditional one is better. And moving the mouse on the bar, you can see the exact value for the traditional network and SDN. So now let's move into the linear and the triangle topologies. Due to the time limit, yeah, I have pre-configured this network to save some time. Yeah, I will just demonstrate the result here. So you can see that this is the linear topology, and we just send the request to the backend. It takes time. Yeah, here. So you can say in this topology, the SDN network shows better than the traditional network. Yeah, and now let's move to the more complex net topology. It's a triangle topology, and we just send the request. Yeah, you can say in this situation, the SDN is better than the traditional network. It's 26, and the traditional network might be this 39. So, okay, so that's all. And thank you for watching our presentation, and we hope it provided you with clear insights into our project. And for any questions or further discussion, please feel free to contact us. And thank you for listening our presentation.